So for P3, we're talking about lines in the plane, it's called. And you guys no doubt have worked with your slopes before. So the fancy thing we use is we represent it with an M. So we represent it with an M, and it's your change in Y over the change in X. So throughout the class, you'll always hear me talk about Y to the sky. So you get your Y's on top, your X's on the bottom, rise over run, however you think of it. Okay? And then when you look at it, so that we can tell them apart, you know, there's x1 and y1, which is your first point. x2 and y2 represents your second point. And then when you look at the formula, it is y2 minus y1 over x2 minus x1. But it doesn't matter what order you do it in, because whenever you guys look at a problem, some of you might say the very first point that you run into is point number 1, and the next one's point number 2, or somebody else, you know, on a graph might take the one on top as the first one, the one on the bottom as the first one. So it doesn't matter the order, you just have to do it consistently the same way all the time. So if I was going to take 4, 3, negative 6, negative 2, so we go M equals y to the sky. So I'm going to put my 3 on top minus the other y value all over 4 minus negative 6. So I've put the y and the x from the first point, put them both first, and the y and the x from the second point second. So what I'm telling you is you could also do it as negative 2 minus 3 over negative 6 minus 4. Now they definitely look different, but as you simplify, the red one will be negative 5 on top, a negative minus 3, so it gets more negative. Negative 6 minus 4 is negative 10, which would be positive 1/2. The purple one, 3 minus negative 2 is actually going to be plus 2, right? Double negative. So that's 5. And another double negative would give me 10 there, which would be 1/2. So that's why it doesn't matter. As long as you identify what you're going to use as your first point, pull that y and x to the front, the other one goes behind, and you subtract. All right? So what I'm going to do is give you a second here, working with somebody near you. Go as fast as you can through B, C, and D. Find the slope, check with somebody sitting near you, find the slope, check with them, find the slope, check with them. And then I'll put the answers up in a second. So I asked you to do B, C, and D, and then we would look at the answer. You should have a slope of 2, should have a slope of 0, and you should have a slope that's called undefined. Does anybody have a question on those slopes? There's a huge difference, remember, between 0 and undefined. 0, the 0 slope is going to tell you that it's a horizontal line. And the undefined slope, remember, is going to tell us that it's vertical, straight up and down. Because the idea is, as you tip a line more and more and more vertical, the slope is getting larger. Well, how large a number can you guys think of? You know, what is the slope of 1,000,000 really a steep slope, or is the slope of 10 million really? You know, and so the idea is your number is going to infinity. So how far can we tip it up straight? That's why it becomes undefined. But you'll recognize that because you end up with 0 on the bottom. Okay? Can't divide by 0. All right. So you should remember a line with positive slope rises from left to right. A line with negative slope falls from left to right. So just some reminders on slopes, positive, negative slope. A line with 0 slope is horizontal. And I think it's on your lecture, but it's not up here. Undefined slope is vertical, right? And let's see if I can go up and down. Okay. So that's just a kind of a reference box. Writing equations for lines. There are different forms. When you come out of Algebra 2, there are different forms. There's slope-intercept, there's point-slope form. So it says write an equation for a line passing through, and then over there they have what is called point-slope form. So you'll notice this is a little bit different than what you guys are used to writing. This is how the Algebra 2 textbooks write it. They put the y1, excuse me. Instead of y1 here, they put y1 there. Now, the only thing I can think of is I grew up with this one. So the red arrow, that indicates the more traditional way to write it. The only thing I can think of is that it's the same. Every time I do a problem, I say y minus the y value of the solution point and x minus the x of the solution point. This one's a little bit different, because this one you're saying x minus the x value of the solution point, and then you're just writing down the y value. So it's not very consistent the way you put the numbers into the problem. So with that said, I really don't care how you guys write point-slope form, because typically in a pre-calc class, I don't allow you to write point-slope form. We always simplify to a y equals mx plus b. We get down to a linear that we would type into the calculator. So write an equation for a line passing through 3, -1. It has a slope of 2. So I'm going to go y minus the -1, and then slope x minus. So I'm gonna always write it this way. If you guys are in a habit of putting the -1 in on the right hand side, go ahead and do it. Okay. So now when we clean it up, this is y plus 1. Distribute the -2, so that's -2x plus 6. All right. Then we're going to take this +1 and we'll subtract 1. Subtract 1. And I get y equals -2x plus 5. So this is what I talk about. We simplify. The most common way to do it is simplify down to slope intercept form. So on number 3 again, it says write an equation of a line passing through -2, 5, 3, -10. So what's different about this problem? We need to find the slope first, right? So let's quickly find slope. M, we use M to represent slope. If you write the word slope, that's just great. 5 minus -10. So I put the y values on top. Y to the sky. -2 minus 3. X values go on the bottom. 5 minus -10 is going to give me a 15. -2 minus 3 gives me -5, and it looks like I'm coming up with the slope of -3. Now, when I go to write my slope, or excuse me, my point slope form, I can choose either one of those points. It doesn't matter which one you pick. So if you're working in groups on a problem like this, I would say, okay, I'll use -2, 5, you use 3, -10, and then we'll see if we come up with the same answer at the end. But anyway, we'll go y minus 5, -2, x minus negative 2. I think one of the common mistakes is people take the number that's on the left and put it on the left, and the number that's on the right, put it on the right. But get your x in the right spot and get your y in the right spot. So if we clean this one up, y minus 5, distribute, negative 3x. Lots of negative signs there. So this is positive 2 right now times negative 3. So that gives me negative 6. And then we will add 5. So we end up with y equals negative 3x minus 1. We're going to cross off number 4. Cars do not depreciate at a linear. You can do the problem and estimate it, but cars depreciate actually at an exponential rate, right? So exponential decay. First year you own a car, it depreciates the most, and then after that, it's fairly steep, and then it'll start to level off. Because when your car is worth $100, you still can't subtract $5,000 value from $100 value. So we've already talked about this one up here, slope, intercept. The slope is the number in front of your x, and then notice your y-intercept. When I say what's the y-intercept, you do not tell me a number, you tell me 0, comma, the number. Do you see that? Your y-intercept is 0, comma, b. A lot of you have gone through math classes and teachers let you say the slope or the intercept is 5 or the intercept is negative 3. That is not an intercept. An intercept is a point, and it is 0, comma something. It's where it's hitting the y-axis, so get in the habit of doing that. One of the easiest ways to work with equations, and this is what's called general form. We'll talk more about that. But we like it when it's in this form because we can find intercepts very quickly. So what we're going to do is make an XY table. When something's in general form, it makes it a lot easier. So the first time I do this, I'm going to make x 0. So if I put x is 0 in, all I want you to do is cover up the 4x. So you put your hand over the top of the 4x. What's left? Y is 8. Now, I'm going to let y be 0 this time, so I cover up the y, and what do you have left? You have 4x equals 8. Well, how do you solve that? Divide both sides by 4, and x is 2. How many how many points do you need to graph a straight line? 2. You might have had teachers in the past that say you need 3, and the third point is just to make sure you didn't make a mistake, right? But 2, I can do a straight edge on 2 points. So 0, 8, I have to make this 2, 4, 6, 8, and 2, 0. So we're going to go 2, 4, 6, 8 also. So I'll make that 2, 0 there. So there's my 0, 8 and my 2, 0. And then we can draw a straight line. And we'll make it in red.